Welcome to The Explainer. I'm your host, and today we're bringing ancient warrior wisdom to modern exam strategy. Think of it as the last samurai, mastering the paper. Because tackling Cambridge mathematics isn't just about what you know, it is about learning to slice through questions with absolute precision. Today, we're getting inside the examiner's mind to master a true titan of the exam, integration and the trapezium rule. Let's look at two typical students sitting in the exam hall right now. We've got Alex and we've got Sam. Alex is a total workhorse. Faced with a complex 0580 or 9709 question, Alex just overloads the paper. We're talking raw mathematical facts, regurgitating every formula known to man, but providing absolutely zero analysis. Then there's Sam. Sam rushes. Sam's eyes completely glaze over the text, missing the specific command word requirements entirely, and just starts calculating blindly. When we put their papers side by side, what do you think we see? It is an absolute sea of red pen marks. Why? Because they lacked a clear, disciplined strategy. Today, we're going to transform those red marks into green check marks by understanding exactly what the examiner demands. Just look at the sheer weight of what we are dealing with here. This massive 15% slice, that represents the trapezium rule in integration for the total marks in paper 2 of the 9709 syllabus. 15%. That is not just some minor topic you can afford to gloss over the night before. This is a foundational pillar of your entire grade. And let me be absolutely clear, this strategic, warrior-like approach doesn't just apply to 9709. Whether you're battling through syllabus code 0580, 0606, 4024, 4037, 4040, or even further math 9231, the core examiner expectations are incredibly consistent. By focusing your energy on mastering the concepts we cover in this explainer, you're making a highly efficient, high-yield investment. We are going to ensure that every single stroke of your pen on that exam paper scores a point.
So, here is our roadmap for the explainer today. 1. Core principles. 2. Technical methodology. 3. Examiner warnings. And 4. Evaluative problem solving. Let's dive right in. Section 1. Core principles. Beyond basic application. If you want to achieve the highest possible marks, you have to realize that examiners aren't looking for a human calculator. They are looking for a mathematical strategist, someone with a deep, theoretical architecture built on precise definitions and causal relationships. It's about understanding the why, not just the how, and this perfectly highlights the exact difference between our student Alex and a truly top-tier candidate. On one side, we have superficial breadth. That's Alex's approach. Alex knows the basic trapezium rule formula, half the width of the strip multiplied by the sum of the first and last ordinates plus twice the rest. Great. But Alex treats this as an isolated, standalone fact. Now look at the analytical depth side. The principal examiner reports explicitly state that top-performing students exhibit connected, conceptual understanding that they can transfer to totally unfamiliar contexts. They make cross-topic connections. For example, they don't just calculate the area under a curve. They recognize that if the curve is a velocity time graph, the area they just slice through using the trapezium rule represents the total distance traveled. Referencing these cross-topic connections is the secret weapon to achieving significantly higher marks. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
So the crucial point here is understanding how you are actually being tested. The assessment targets 3 distinct cognitive domains. First, knowledge and understanding. Basically, do you know the formula? Second, application. Can you plug numbers into that formula correctly without messing up the arithmetic? But the final tier, the ultimate battleground, is analysis. This is where academic benchmarks require logical, structured reasoning. This is where you have to decode the command words in the question. Does the question just say calculate, or does it demand that you evaluate or show that? Top candidates conquer this analysis domain by using the PEEL framework. Point, evidence, explanation, link. You state your mathematical point, you show your working as evidence, you provide an explanation of your reasoning if the command word demands it, and you link it right back to the context. That is how you structure a winning answer.
Section 2. Technical methodology. The method mark strategy.
This part is absolutely vital, so pay close attention. In Cambridge mathematics exams, marks are explicitly awarded for the process itself, not just that final calculated value sitting at the bottom of the page. You could literally make a simple arithmetic error right at the end, but if your methodology is perfect, you are still going to secure the vast majority of the marks. This 4-step framework, what I call the mathematics success blueprint, is what you must use to build a robust answer. Let's look at how this transforms a student's performance in real time. Remember our rushing student Sam? Sam sees a complex trapezium roll question and instantly starts plugging in numbers. Zero structure. But if Sam applies this blueprint, everything shifts. Step 1. Identify given information. What are the limits of integration? What is n, the number of strips? Step 2. Break into logical steps. Calculate the step size, h, first. Mop out your x and y values in a clean table. Step 3. Solve systematically. Apply the formula clearly, showing your substitution. Step 4. Check for reasonableness. If you're calculating an area that visually looks to be about 50 square units and your calculator spits out 5,000, you need to pause. By forcing yourself to write answers this way, those red pen marks transform into green check marks. You are showing the examiner the precision of your mind.
Practical application develops professional skills. And let me tell you, presentation conventions are strictly enforced. Look at these rows. Proper headings, correct terminology, clear annotation. If you're setting up a table of values for the trapezium rule and you fail to label your columns clearly, or you use sloppy terminology when explaining if the rule gives an overestimate or underestimate, you are going to hemorrhage points. An incorrectly applied presentation convention simply tells the examiner you lack rigorous discipline. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, it's time for an interactive workshop. I want you to imagine a complex mathematics data table right in front of you, showing coordinates for an irregular curve. We're going to do challenge 1, the data scan. Imagine a 60-second visual countdown timer ticking down right now. Go. What do? Your job isn't to frantically start doing arithmetic. Your job is to extract, interpret, and conclude. First, extract the core trend. Are the y values going up or down? Are the intervals between the x values uniform? Extract the data precisely. Next, interpret the relationships. If the curve is convex, what does that mean for our trapezium rule approximation? Finally, draw evidence-based conclusions. If they want an interpretation of the area, you conclude based purely on the specific variables provided. Time is up. That mental process right there, extract, interpret, conclude, is the exact data interpretation skill the syllabus requires. Section 3. Examiner Warnings. Top 3 Student Failures. We are pulling back the curtain and looking directly at the principal examiner reports. These are gold mines because they reveal the top 3 mistakes where thousands of candidates fail every single year. Let's do challenge 2, find the flaw. I'm going to read a sample answer from our student Sam. I want you to spot the exact sentence that loses marks. Here we go. I calculated the area using the formula. The answer is 42.5. This is an underestimate because the curve goes down. Okay, where is the flaw? The examiner commentary would absolutely rip that apart because it hits all 3 of these bullet points. First, it's way too vague. Which formula? What were the specific ordinates? Second, format. Where is the step-by-step working? And third, and most importantly, it is not specific to the context. Because the curve goes down is not valid mathematical terminology. Sam should have stated that the second derivative is positive, indicating the curve is concave up, meaning the straight lines of the trapezia lie above the curve, resulting in an overestimate. Sam's rushed answer just cost almost all the available marks. This brings us perfectly to this quote, straight from the principal examiner alert. The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. Let's jump into challenge 3, speed writing. Imagine a 30-second timer counting down. Your task is to write 1 perfect paragraph using the Peel framework. Point, evidence, explanation, link, explaining why a trapezium rule calculation of a river's cross-sectional area might not be perfectly accurate. Ready? Go. Okay, your point should be that the riverbed isn't composed of perfectly straight lines. Your evidence is the jagged, irregular nature of natural terrain. Your explanation is that the trapezium rule inherently connects ordinates with straight lines, missing the curves. And your link, this is the magic part, must tie back to the specific river context provided in the question. A generic, copy-pasted formulaic answer without that link is a guaranteed 0 for analysis. And that is exactly what contextual linking is all about. This defines it perfectly. Explicitly connecting your mathematical findings, your steps, and your assumptions back to the specific scenario provided. If the question asks you to calculate the volume of a manufactured part using the trapezium rule, your final sentence shouldn't just be a naked number like volume equals 104. You need to acknowledge the context. The math has to serve the narrative of the question. This is exactly what separates a student who only knows the mechanics from a true strategist who understands how mathematics applies to the real world. Section 4. Evaluative problem solving, securing the top grade. Notice the evolution of critical thought here. This is the evaluative phase that separates passing students from the absolute top-scoring candidates who dominate Cambridge exams. On the left, basic comparing. This is just noticing that two methods give you somewhat similar answers. But on the right, we have critical comparing. This means identifying similarities and differences, using comparative connectives, deploying hard evidence from your working, and drawing relative conclusions. This perfectly ties into the final system, the 3 rules that guarantee top marks. Rule 1, command word decoding. Rule 2, Peel framework application. And Rule 3, the time management matrix. If a question asks you to critically compare your trapezium rule estimate with an exact integration using calculus, saying they are close won't cut it. You must use your time management matrix to allocate enough minutes to write a real critical comparison. Something like, while both methods yield a positive area, the trapezium rule overestimates by 2.4% because the curve is convex between x equals 1 and x equals 5, as evidenced by the positive second derivative. That is how a master slices through a critical comparison.
To consistently execute at that level, you must fulfill these quality evaluation requirements. Top candidates show evaluative thinking by relentlessly questioning the given assumptions. You have to identify limitations, like pointing out that using only 4 strips heavily limits the accuracy of your approximation. You must highlight assumptions made, like assuming the curve is monotonic between the data points. You must consider alternative interpretations, and most importantly, assess their effect on the final conclusions. Ask yourself, if this assumption I made is even slightly off, does it completely invalidate the final number?
So I want to leave you with this provocative question as you head into your next study session. Look at your past paper practice. Are you questioning your assumptions, evaluating evidence, and checking for reasonableness? Or are you just like Sam, blindly racing to the final number? Mastering the trapezium rule, mastering any Cambridge paper requires you to slow down, deploy a clear strategy, and think like the examiner. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @theacetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.